Okay, got it. Hi, everybody. I'm Mari Spina, and I'm from MITRE Cyber. And I actually led a collaboration, or I was part of the team that led a collaboration that ATARC hosted. And let me share with you the screen that has that content. Let's see, will it go? Tell me if it's going where I wanted it. Is it, oops, is it here? Can you see the faces?
Yes.
Yep.
Okay, this is the Orion Collaboration faces. Does it say Orion?
Yep, looks good.
Okay, okay, excellent. So a bunch of us gathered and we named it Orion. It actually had a few names, but it started out a collaboration fundamentally around getting to agile ATO, right? And that is sort of continuous ATO, where everything is automated. So hopefully it's very easy, right? And the workload and the effort is reduced. And we wanted to sort of found the whole thing on OSCAL, and OSCAL is the NIST Open Security Control Assessment Language. And so we said, okay, if we're going to really do an ATO thing, let's set up a real environment, right? Let's have, let's use the cloud, let's set up
Whoops, I think we lost you, Mari.
and systems, the most well-known zero trust perimeter. So we engaged Waverly Labs, Juanita Coilipe, and you may know her. So she brought OpenSDP for us and a lot of vision, Through that vision, we developed the blue-green development environment, and I'll show you what that is. And the SDP solution brought TIC 3.0 capabilities. And I actually joined the collaboration because I was very interested in TIC 3.0. And I wanted to see how we could use the TIC 3.0 capabilities in a DevSecOps security scenario. And so what we did is we said, okay, well, SDP can give us some of the TIC 3.0 capabilities. So let's look at SDP to give us that and see how good the software-defined perimeter tool is against the TIC 3.0 requirements or capability requirements. And then we said, okay, well, in order to do this agile thing and keep everything automated, we'll bring the MITRE Security Automation Framework. It's SAF. And that proved very, very effective. Some of you may know it employs a tool, and I see Eric there with me. Some of you may know it employs a protocol called InSpec, which is sort of a machine read and writable code that can be used to automate the testing of security configurations on a computer box. Do you see the document? Oh, I'm sorry, before, yeah, can you guys see the document right now? I brought it up.
Yeah, looks good.
Okay, I'm sorry. What I want to do before I go to that is I did want to let you know, I don't know, I know I have Yolanda and Eric here from the team. Is anybody else here from the team?
I think Henry was part of it as well. No, Henry?
Travis Howerton's here, Mari.
Oh, hi, Travis. Yay. Okay. So what I wanted to do was sort of let you know some of the key players. It's not just the people here, but Michaela Iorigas, some of you may know from NIST. She was definitely a big proponent of this. In fact, I called her the cheerleader and choreographer because she was able to orchestrate this entire group together. And she has a very unique way of telling a story, and not to mention bringing people together and building great friendships. So if you ever have a chance to work with Michaela, please do. Now, we dedicated the name JK21, Orion JK21, because we lost Juanita Coilpile. from Waverly Labs. She actually died in a sort of a not happy thing towards the end of last year, as we were really making some progress and getting some things done. So we really missed her, and it was a sort of a loss for the whole industry, because she invented software-defined perimeter. And then Anil Carmel, who and Travis works with Anil. Anil and Travis just stood up a company called Reg. How do you say it, Travis?
Reg scale.
Reg scale, like regulatory compliance at scale, right?
Yep.
And so through Anil as CEO at the time for, it was C2 Labs, him and Travis helped us push and advance the use of OSCAL in compliance tools. And so you'll see some of that. In addition, Greg Allen from GovReady did a similar thing with the GovReady tool. And so if you go to GovReady, you'll see the ability to process OSCAL. AJ Stein came from us from GSA and is now with NIST, and helped us do some real detailed mapping between the InSpec syntax and OSCAL. And so what you'll see is a capability, and it was AJ's brainchild that was able to take us from an SSP produced in OSCAL to a machine readable code set that could be tested on a box to test essentially like STIGs, right? Or configuration compliance. So I did mention Yolanda and Eric from Federal Reserve Board, all key contributors to the paper. So with that, let me go ahead and get to the paper. Okay. It shows that bar in my way. All right, so so in terms of the contributors, you see it was quite a large staff of contributors. And this kind of thing can be really exciting when you have folks that, are able to participate. So it was really fun. The reason I'm using the document is because I don't really want to have a slide deck that everybody says, hey, send me your slide deck. I want you to go to the document. We worked hard on it. It's a decent document. It has the links. There's a GitHub link or a GitLab link that has the artifacts and some of the papers and presentations that we produced. At one time, right, Kirsten, about, was it June or July of last year, we actually did a video presentation.
Yeah, and that's also on our website. If you go to our cloud mission area, you'll find that recording there.
It was an ATARC like roundtable, and I hosted all the folks I just mentioned. And they went and talked about, each of their various contributions, which were still in process and not quite done. So what I want to do is take you through some of the sort of core concepts in the document. And so let's start off with, I want to get to the diagram. Okay, so we started out with a computer environment, right? And we had 212 E3 labs donated an infrastructure as a service cloud for us, and essentially 4 workstations. And what we did is we built a DevSecOps environment. We did a blue-green thing where these are separate virtual machines, where green is established for sort of development or software staging. And then ops is the thing that a user has access to. And we fronted it with software-defined perimeter. And essentially we call that in the zero trust parlance of the NIST 207, 800 SP 800 207 document on zero trust architecture. This would be a PEP, policy enforcement point. And the controller of it, the software-defined perimeter controller, we called ICAM as a service or identity as a service, it would be the PDP. And so I didn't actually list that here, but it would essentially be the PDP. It actually also does identity. And a lot of folks don't understand that, you know, when you're doing an SDP controller, you actually have a full identity service running. But what's very interesting about this is just take a look at the different data flows. And it's actually a complicated thing, right? To host development and production in essentially a single VPC or a single enclave. And you know, it's not something that you would typically want to do, right? So it's a strenuous case on for security and traffic control. But so the SDP was able to segment out the various traffic types. And of course, going through essentially the same gateway, you've got users of the application, you've got managers of the system. And you know what? I wonder if I have, oh, gosh, I'm looking at my diagram. I don't know why I have users going into the staging environment. I wonder if I actually was able to update this or missed it. Anyway, suffice it to say that you've got managers, developers, and users, and they all have to be able to go to the right place. So in so doing, right, we ended up with this sort of responsibility stack, and Eric was a key contributor to helping us understand what it meant to do what I like to call inheriting controls, right? And Michaela said the best term to use is leveraging ATO, right? And so 212 had their own ATO, Waverly had their own emulated ATO. They were actually still trying to get a real one. And then we said that this F-Force application is just an application we're going to run in the environment, and we're going to run it for a group serving a set of consumers. And so we ended up with this inheritance model. I may have to update this diagram, Kirsten. Is that still okay?
Yeah, of course.
Yeah. Okay, so recognize that the data flows make this a complicated thing, but we wanted to put the system under stress. We wanted to do something that you wouldn't typically do, you wouldn't want to do, and see if we could develop a sense of security and trust from implementing the SDP to do it. So we had a real environment. It was set up like this. When you read the paper, most of these IP addresses you can still hit, I think, and so folks need credentials. I think we can probably get you onto the system if you want to use it. What, am I right, Travis? Do you think they're still up? As far as you know?
I'm not sure.
Yeah, I don't think anybody scavenged them. We'll have to ask Ton. So you can read through the software that we had on the system. And let's see, what did I want? Do I have the trying to figure out which of it does it show the MITRE SAF stuff on here. And I think it's in, is it, no, it's not actually on here. I think the MITRE SAF was run from the outside. Okay. All right. So given that, again, more on the environment, you know, and how it leveraged the 212 system and how we were running a control. These are the four components: the controller, the blue, green, and then we had a tester virtual machine as the sort of not as the adversary, as the actually designed to initially emulate the adversary, but also the machine we did testing from. Okay, So here's what we automated. And what we were able to show is GovReady was able to take the SSPs, and we actually created one for the app, the F-Force app. We had one for Waverly Labs, and we had one for the E3 212 E3 lab, infrastructure as code. I'm sorry, infrastructure as a service, IaaS. Now, we didn't get to the point where we could show that inheritance, but we wanted to. But what we were able to do is show that if GovReady could, ingest the content from an SSP, it could render it in OSCAL, and it does that. It does that today. Folks may question what version and whatnot, but in any event, it was able to do a version of OSCAL. And in addition, we had a company by the name of CFocus, and it was Jason, I can't remember Jason's name. Jason helped us with his service, ATO as a service, which can now do the same thing. So the point is, you're beginning to get products and tools that can ingest SSP content and output OSCAL. Some products can actually ingest OSCAL and put out OSCAL. So you'll notice the Atlasity tool, which Travis, is it still called Atlasity?
No, it's now RegScale.
It's RegScale. Okay, so the company name changed and the product name changed. Okay.
Yes, ma'am.
Yep. Sorry about that. Well, you did change kind of when the paper was being published. So Atlasity is an interesting tool that was sort of able to pull it all together by taking the OSCAL-based SSP and helping us develop a system assessment plan using the MITRE inspect profile content. Then the MITRE secure automation framework, which uses this inspect profile concept, is then run against the actual platform and tests, right, for compliance, the boxes that were deployed, and then spits out the results so that Atlasity could render a system assessment report. It turned out we never did get to the POAM concept, but we could have. We just didn't end there. But essentially, these products, SSP, SAP, and SAR, we showed how it could all be done basically by sharing, ingesting, or outputting OSCAL. So that was good. Now, one of the things you may recognize is that somehow you've got to create an inspect profile so that you can test on the box. Again, this is the machine readable and writable stuff that you want to test compliance to, right? So you've got to convert from the content in OSCAL to the content necessary for testing against a STIG, essentially. Consider it like a STIG. It's very much like a STIG. So one of the first efforts, and I'll just go through some of the GovReady stuff. Here's the example of GovReady giving us the SSP content and giving us screens and windows to output our input our stuff in. You don't see the actual content. If you go to that GitLab, you can actually see some of the OSCAL output, but that's a little bit boring for this. And then at this point, you're looking at ATO as a service, doing the same thing, all talking in OSCAL and giving you an easy to use compliance window. Okay. What I wanted to get to is, let's see. So one thing that we did learn from, doing all of this OSCAL import and export is definitely an appreciation and a better understanding for the OSCAL data models. In fact, I might ask Travis, do you feel like saying any words about that? I would have to say, as an engineer, it's fairly complicated. It's fairly rigorous. And NIST spent a long time on it, trying to get it right and to be usable across the industry. Travis, you want to say anything about the OSCAL model?
I think ultimately we found we were able to do everything we needed to do with it. You know, the beauty of OSCAL is the complexity of the model, that it lets it model almost anything, which is needed in an environment, sort of systems of systems environment that's very complex. The downside of that is there's a bit of a learning curve, and things aren't always where maybe you intuitively expected them to be. And so there was just a little bit of learning curve in engineering to overcome, but ultimately we were able to use the 1.0 version to accomplish the end-to-end goals. So at the end of the day, OSCAL works. We're able to give them feedback on what we liked and what we didn't, and hopefully help drive some continuous improvement to the standard as a function of time.
Yeah, and the component, or the part of the model, the OSCAL model, that became very useful for the MITRE SAF and the InSpec integration, or the translation to the InSpec profile, came in the component model. And we were able to essentially expand and extend the component model to help us pass the parameters to InSpec. And so let me go. Oh, and so that's this notion of sort of a lack of strongly typed parameters. I'm going to get to an example of that. So what we found was, you know, when you looked at the SSP content that was being entered, there could be a lot of free form text, right? But when you get to the machine readable, testable code, you know, that the InSpec profile wants to use to test a configuration of a computer, it has to be very specific, right? You know, specific strings or numbers or Boolean logic, even arrays, right? Or key value pairs. And there wasn't a lot of that to actually deal with, because if you look at how, for example, if you take a FedRAMP SSP generic input template, you'll see that the fields are pretty free form, and you can almost write, you know, anything you want in there. And so we started to think, you know, there may need to be this sort of namespace, right? And here's one sort of example, right, we ran across. So we were talking about the number of max logins, and here you have this sort of free form definition, right? Well, and this is the author of the SSP for the system writes, well, it's 3 sessions for privileged access users and 2 sessions for non-privileged access. That's just an example of the kind of content you can get, but InSpec is looking for it to be very specific. You know, max logins, it's a number, and the value is 10. So test a configuration and tell me if that's how this box is set up. So we struggled with that, and we said, well, you know, this SSP content is going to be very organizational dependent. You know, some organizations are going to say it one way and some are going to say it another way. And oh, by the way, each of the authors may have their own way of saying it, and the systems may have different ways of saying it. Imagine in this context, if you had 4 or 5 different types of users, you'd have an array, right? Now, OSCAL wasn't set up to give us an array of values, right? So we had to do something to extend that. Here's another example of an actual string that, you know, we're looking for a date string here, and here we're sort of given words, right? And it just doesn't It doesn't correspond. So it's not something I can take and go test. So we had to do a translation. An industry, to do what we did, to continue our efforts, will probably have to do their own translations. Let's see. Oh, I took out that, I think we took out that translation. So anyway, suffice it to say, there's not a good example of the translation. We had to make one work for each specific test. Okay, I thought I had the namespace thing in here. Give me a second. Oh, I do. Okay. All right. So here's us. We made an inspec OSCAL plugin, we call it. But we called it an extension model, right, Travis? And what we did is we made Travis parse those words essentially and put it into an extension model that we predefined for him. And so that extension model and the inspec that it renders, right, is essentially called the inspec OSCAL plugin. And you can click on that and go get it. It's not guaranteed. Oh, here's the model. It's not guaranteed to work for everyone, but we're hoping to get more users on it to see where it breaks. And so here's an extension to the OSCAL component model to reuse the component model to glean the stuff that's important for inspec and then put it out in an inspec runtime code. So this was sort of the revolution in what we did to make it so you could go from OSCAL to testable to automated testing. And that was the key here. So I urge folks to read up on that and see if they can apply it, see if they can download our inspec plugin on the MITRE SAF site. And then as a result, this is where the notion of the namespace came. In that, right, in order to do a mapping from one organization's way of phrasing things in their SSP to machine readable code, you may have to come up with things that say, a sentence like this is an array, and here's how the array looks. And that was the kind of thing that we actually attempted. And at some level, we were successful. It wasn't an exhaustive. We didn't do it for all controls. I think in reality, Travis, we only tested a few controls in that way, right? We're only able to map a few.
Yeah, it was just a subset for proof of concept, not a full scope.
Yeah. So this namespace mapping of let's say free text to to discrete parameters, that's the notion of the namespace. We didn't actually have a really good version of it, so I didn't put it in here. It was actually too hard to comprehend. Okay, so that's the notion of the namespace. More on this. So the important thing was we were able to go from the OSCAL to the Heimdall renderings of the inspec profile tests, right? And so here we're showing an Ubuntu STIG baseline. We came up with a profile to test OpenSDP, as well as to just test against generic Ubuntu. And so here we're just showing that our profiles, the MITRE software automation framework inspec profiles actually worked and gave us results. Now, these results were then ingestible by Atlassidy and renderable into a system assessment report. And I'm actually coming up on that. Okay, but before I go to that, just just a note, again, we ran the inspect profile against OpenSCP. So one of the products we got out of this, and this is just showing the things that were checked. This is the hardening test. Is we actually got, you might call it an inspect profile for OpenSCP. So for those of you out there in the industry using OpenSCP, you have essentially an automated STIG to go against in the inspect profile. And if anybody wants that and can't find it after going through the links in the document, then let me know and I'll get the MITRE folks to dig it up. Okay, so all right, so we came up with that, and it was the two profiles. And this is just showing, you know, how does it work? How does the TIC-3O testing, how did the TIC-3O testing work? And again, this is when we say TIC-3O testing, we ran the profile against to assess the SDP system, right, against TIC-3O capabilities. And so that's what we're saying when we say TIC-3O testing. And so we have a profile like that. We came up with two profiles for OpenSCP. One is just general hardening, and the other is against TIC-3O capabilities. Okay. And all right, so we detail some of that testing. We jump around a little bit. But again, we ended up getting the Heimdall results, which are part of the MITRE software automation framework, and, you know, very compliance related, tells you how many things, you know, passed and failed. These are capabilities, not necessarily controls. Typically, they are controls. And so you'll see here, the way these IDs are specified, they're not control IDs like AC1, AC2. They're actually TIC-3O capability names. If you look at the TIC-3O document for network PEP, it was a network PEP. Okay, so that's a really powerful result in that we've got this profile you can grab and go test your OpenSCP tool against two inspect profiles. One to test it again, is it just generally hardened? And that was, what did Waverly Labs tell us the secure configuration was? It's like the benchmark. And then another profile for testing against the TIC-3O capabilities. And so what I have here now is just an array of the various outputs that the Atlasity tool was able to generate. And I think folks would see these things now in your reg reg scale, right? Right. But does it look the same? It says reg scale instead of Atlasity.
Yeah, it's got a little bit of a makeover, but functionally it's the same.
Functionally, okay. Is there anything you want to talk about, Travis? I think it's really important to show that behind the scenes here is OSCAL, but you're giving a nice graphical user entry capability. And so the point is, when folks interact with it, they can actually output an OSCAL.
Yeah, and so there's sort of two pieces of this. What you see here is sort of the GUI side of it, the graphical user interface. And basically you can think of it as a free OSCAL content authoring tool. We support the catalog through the security control, system security plan component, SAP, SAR, POAM, sort of full stack of OSCAL at version 1.0. And the idea is to give people approachable free tools in a GUI where they can take their content and sort of manually recreate it and export it as OSCAL and do automated things with it. And so We've done a fair amount of that. The other thing that's interesting about the tool is everything that's in the GUI is also available as an API, it's an application programming interface. And so what we do with a lot of folks we've worked with is take their spreadsheets, their existing database, they have this type of data in, we script it in through the APIs, and then we use the converters that are in RegScale to convert that over to OSCAL. So it's a way to quickly go from spreadsheet control-based framework over to an OSCALized version in an hour or two using sort of modern scripting techniques and APIs. And so we're able to demonstrate a lot of that. We also had to add a whole bunch of things for the 1.0 standard and the OSCAL schema we didn't have. We had no concept of components. We had to build that. There were missing pieces in our schema. So to get it to pass validation, we ended up adding quite a bit of features and functionality to the platform. You can see there with the AJV integration, that's another JSON validator. We were able to bring in the NIST validators so that you know what's going to pass or fail an OSCAL validation inside the platform. And so subsequent to this, we're now even working with the FedRAMP office to take their validators for OSCAL and pre-score those as well. So we continue to sort of build on this. It's kind of a layer cake where OSCAL is the foundation, and then we keep adding capabilities around it to make those automations and more efficient for folks. And so that's a little bit about that piece, Maury.
Yep. Passing OSCAL parameters. Here's your summary file of sort of what that ended up looking like. You want to say anything about it?
Yeah, so when you saw the GUI, we have utilities in RegScale that let you take any of the records that are in the OSCAL stack. So the 5-6 modules that are part of OSCAL, every one of those has an export option. One of the export options is the OSCAL side, which basically dumps out this compliant JSON file in the OSCAL version. So this is a component definition. We've got some features and functionality in our platform, like version control, where you can see which version you're on and the previous versions all inside the OSCAL. So we really tried to exercise as much of the schema as we could with the metadata that we had. So we had all the required fields, but then over time, we added more and more enrichment of optional fields to give more of a complete system model of what's in that component, all of which passed validation. And this file is ultimately what we sent to the MITRE SAF team to go do their scan with Heindel.
Yeah, and the scans were done from the outside. We didn't show the scanning box. The scanning box was a MITRE SAF box.
Mm-hmm. And one thing that's kind of important here, when we originally did this like a year ago with the MITRE team, we coded a lot of the parsing of the HDF file that came out of InSpec. Subsequent to that, MITRE was kind enough to publish an NPM package that took my massive library of stuff I had to do and knock it down to a couple lines. So it was beautiful. And so we refactored all that using the MITRE tools, which make this stuff a lot easier than it would otherwise be. So did want to give kudos to Aaron and that team for putting out some great tools so that if you're deep in the weeds, you know, this stuff's hard enough without getting into low-level data processing, and MITRE really made it easier for all of us to deal with this data by publishing that package.
Awesome. Yay. This was your ability to go in and out of different tools, right?
Yep. This is where we had to do some things around namespacing. So we added support for that so that we could basically use that extension model in a namespace. So we basically gave an admin panel for configuring that. Same thing with the MITRE SAF integration. We built an admin panel that would take that inspect library, take the output of the component scan that run, parse it, create all the assessments, attach the issues or POAMs that came out of it, and sort of log all that in a nice UI where you could see a progress bar. And then when you export, you get the SAP SAR that came out of that sort of all automatically, you know, just using the power of OSCAL to port stuff between different tools.
Awesome. Parsing, so using that special file you said, right?
Yep.
helped you get to this, where your tool is outputting the miter Heimdall results.
Yep. And so it's taking the way MITRE does it. They've got their own schema for how they track this stuff. We have a different schema, but we both talk OSCAL. And so we're able to use that inspect library, translate things, and get a very precise mapping of what controls were scanned, so we can update the assessments of those controls, and then take any remediation actions we need to for the ones that fail. And you can see sort of the results as it progresses, as would sort of output to the screen what is a time as it processes the file. And you can kind of see what's going on under the hood.
Yeah, that's really pretty, really nice. Awesome. Okay, then by extension, right, all that OSCAL and inspect interaction gets us to an assessment report.
Yep.
And the profile leads to an assessment plan.
That's correct.
And those are completely translated from the inspect input to OSCAL.
Yeah. And so basically we take what we have in the parameters as inputs with what the STIG is scanning. We basically derive a SAP of what we're assessing, run it, and then the results of the scanner, which is the MITRE tool, are parsed by RegScale to generate the SAP SAR and OSCAL, which is the ultimate end result of this.
I think that's it. I don't think we showed the assessment report, except for the GUI that we showed.
Yep,
Yeah,
that's correct.
So thank you very much, Travis.
You're
So,
welcome.
you know, we really did something important here. We showed the notion of compliance as code, policy as code, enabled by an industry, what we hope is accepted as an industry standard, the NIST OSCAL. It's very, very deep, has a lot of detail that, you know, should support most industry efforts. We did find the gap, right? The gap was going from OSCAL to machine readable code for testing to automate testing. Now, that's not necessarily OSCAL's problem, right? Some of it has to do with just, you know, human language and how people are used to, how security folks are used to filling out the SSP questions, right? And data fields, which left us with that sort of quandary. But we were able to produce a model, and we have some plugins, right? And some components that folks can use and try to redo this if they want, or get the reg at scale, or even the C-Focus tool, which is, you know, should be enabled to do. We know reg scale is. GovReady, I think, is not necessarily there with integration of the MITRE SAP. And then I think the C-Focus tool, ATO as a service, is working on it. So what we want to do is be able to have that full loop automated, right? So that we can do continuous ATO. Now, what do we mean? Okay, every time a system is updated, and even before it's deployed, we can test it, right? If you're in a blue-green environment, you want to test the green before you turn it to blue, that kind of thing. And so if it's automated, you can be very dynamic. But we still find that in the industry, folks want the document, right? And I think Eric was the one to help us understand this. And Yolanda, that you're not going to get away, particularly, you're not going to get away from the documents. People want the artifacts. The authorizing officials, the cyber security managers, they still want to see the artifacts at some point. So you don't want to lose the capability to produce the artifact. And OSCAL gives us that, it retains that, as well as provides a foundation to render from, as you saw with the Atlasity tool. So overall, it was a really good collaboration. We did examine quite a number of aspects of OpenSDP. We didn't comment on how good it does TIC 3.0. We'll leave that for someone else, but we were able to test its TIC 3.0 capabilities using the inspect profile concept. And that was good because, you know, we are talking about zero trust and we don't want to forget that. And OpenSDP can be a great tool to secure a complicated data flow environment. And so that's why we showed it. So I guess with that, I'll just leave it for questions. It was fun. We all made a lot of great friendships. And so I'd urge everybody to get the paper and check it out. Check out the engineering behind it.
Thanks, Mari. And
Yeah.
before I give any updates, is there anyone who has questions for Mari and the rest of the team?
I was just going to ask Mari about the, you know, when we looked at the input-output variant, and is that going to be the next phase or revision of maybe cleaning that up or finding a solution? Or did we find one during this first round to that input-output where the text versus the versioning? Was that up in the, I think it was on or further up. I don't remember what page that was.
What are you?
The input output for
Oscar?
yeah, when you were doing the testing and you said, you know, when we were saying how it's not 100%, we still have to have eyes on the ground and editing and mapping.
Oh, well, I think that's the name. That's potentially the namespace issue, which is why Atlassian gave a GUI to help you do it. Basically, you could click on, you know, one of those sort of basic namespaces and then modify it. I think your plan there, Travis, was, you know, click on, you know, a MITRE namespace and see what of it you like and make your own, right?
Mm.
Yeah, I have to look at exactly how we coded that, but the idea is that you could kind of define them and then use them for different things. That way you wouldn't have collisions and variable names and other stuff. You could cleanly namespace the extensions and kind of do what you need to do for specific bespoke integrations.
Yeah.
Mm.
Yeah, I don't, you know, the one thing we found, Yolanda, is that various companies are at different versions of OSCAL.
Mhm.
And so, you know, a complete collaboration takes everybody to be at the same version. And, you know, I know that GovReady is working on getting to the next version. I think Atlassian and CFocus are ahead of the game. So I'm not so sure we're going to have another collaboration on this. I think we really did sort of prove a concept for the industry. You know, it's sort of at a point where you'll begin to see it like you do in Atlassian and CFocus and GovReady. And it'll just, hopefully it just continues to evolve.
Yep.
May I ask a question? Hey, Kirsten.
Yeah, absolutely.
Yeah, excellent proof of concept. I read your paper earlier today. I think there's a lot of wealth of information out there. So I actually, this is two-part question. One of them is level of effort. So how long would it take, so based on your proof of concept, if I'm a government entity or industry, to take this and then integrate it within our, you know, A&A processes?
Oh, good question. So what we experienced was sort of the hardcore coding, right? We both GovReady, CFocus, and Atlassian now Red Scale through Travis. And do you still have your other programming person, Travis, working?
Oh yeah, Juliet's still on the team.
Juliet, yeah, Juliet. They just did tons of programming, and for a volunteer activity, the level of effort that Atlasity put in was extreme. And I would say many hours every week to get us to the point where we could show what they showed. If you have a tool, Babar, and you had to start programming it, I would say you're a good, if you have a good programming development team, probably 6 months away easy, right, Travis?
Yeah, it was, our kind of philosophy was we love OSCAL. We're completely bought into the vision of it and the problem it solves. Sort of our thesis on it was, without tools, it's going to be hard for people to adopt it because of what Mari just said on that learning curve and the time and the skill sets needed. Not everybody has it in their A&A team. And so our goal and what we wanted to contribute to the community was a free platform where you could just leverage our GUI, maybe script something in the APIs. Like we had another customer we worked with where we took NIST 171 that they had broken out in a spreadsheet they've been using. We scripted it in, and 2 hours later, they had OSCAL for NIST 800 171, and they were off and doing their thing inside of a GUI, right? And so our goal was to try to sort of take some of that on, right? And I think the other tool providers are not a marketing thing for us. GovReady's a great tool. So is CFocus. Others are coming on, so it's just kind of, you can look at what each tool does well or doesn't do well, kind of decide. But we wanted to put some free tools into the community that kind of bring that barrier to entry down, so that if you are interested in exploring, it's not a huge project you got to get funded for. It's maybe a weekend project where you can hack around and see how far you can get it. Yeah.
So the point there is, if you're a developer and you want to build your own tool, I say you're 6 months out, and it's a hard slog. But if you can leverage an as-built tool, right, like the Atlasity, potentially the GovReady in the future, and the CFocus, and others, hopefully soon, then you could do it a whole lot quicker. My sense is, if you grab the Reg Scale tool, you could probably be up and running in a few weeks, actually beginning to put out OSCAL and share data about, in the OSCAL format. Wouldn't you say, Travis? A couple weeks.
Yeah, I mean, that was our entire goal, was to accelerate that. And so I'd say just grab a tool, use it till you break it. I'd also say the other point we found in this is, like, the more mature your tool is, the more data it has in it, the older its schema is, and how variant that is from the OSCAL schema can kind of crush you under the weight of it. So I think it's going to be tough for old tools to OSCAL enable themselves. We had the advantage of being relatively new to market, and we had kind of aligned to this all along. So I think if your schema is close, it goes faster. If you've got to move a ton of data and your schema is way off, it's either going to take a ton of time or be impossible.
Yeah. Great
Excellent.
question.
May I ask one more? I don't know if we have time. So this is in terms of, you have Agile ATO mentioned. Agility is important. So there's CI/CD, continuous integration, continuous diagnostics, that industry and the government talks about all the time. So may I take this proof of concepts and integrate it within my, say, DevOps server, which we have everything code as a service in our cloud environment, or do we have to use the tools and technologies mentioned here?
No, I think you could integrate it into your CI/CD pipeline tool set. I think how you would integrate it is, you would want to make it your interface for the RMF ANA, I call it assessment and authorization artifacts, so that you could start your pipeline with an artifact like SSP, right? And end your pipeline so that when stuff is finally, say, delivered, then you're outputting, or along the way for decision makers, right? You're outputting the SAP and SAR, and then the POAMs if necessary. So I would put it in to your CI/CD or DevSecOps pipeline, particularly to provide that artifact interface, so that artifacts can come in, test results can come out through artifacts. like the SSP, the SAR, and the SAP and POAMs.
Yeah,
Because you're not, those aren't going away.
No, and we're seeing a lot of companies we work with integrating their continuous monitoring and their CI/CD tools into us with APIs as part of their continuous ATO journey, right? So the goal of, if you've got everything, infrastructure as code, having a compliance as code, OSCAL tool, whatever that may be, that works alongside it as part of that pipeline is a sort of powerful end state when you can get there.
Yeah, good question.
Thank you. So that brings me to my last question. I promise it's the last one. So what about technical implementation? So you mentioned DoD sticks. So a lot of civil agencies, they don't use sticks or the DoD version of it. And we don't have the stick viewer and all those other cool stuff. So this is a lot of, my understanding, a lot of really cool policy aspects of it. But what about automating some of the implementation of the security controls, say NIST 853? Is that kind of
Yes.
embedded into this?
Yeah, so if you go right now to the SAF at MITRE.org, you'll find an array of profiles built by industry that incorporate STIGs and benchmarks, not just STIGs, but STIGs and benchmarks like the CIS benchmarks into an automated testing capability. And there's a lot of testing profiles built, but not all of them. So you may get to a point where you need to engage the SAF community and say, hey, would you guys help me build this new profile? How would I do it? You don't need a STIG viewer for it. You don't need a link to the STIG database. You can just grab the profile and just, rest assured and use the README to figure out, does it have the latest STIGs if that's what you're concerned about? And you can learn to write it yourself. So, MITRE built the SAF to be easily modifiable for an organization. So you could have your own Ubuntu profile, but there's a lot there already.
Thank you.
And that's all free. That's all public use. And there's a community around building it if you're so inclined to engage it.
All right, so we are almost out of time. Just a couple things in the chat I wanted to share with the folks who are online that we're spinning up a new working group at ATARC around multi-cloud. We actually had some of the chairs online for this, Baber and Sid Serpata over at GSA, he was on earlier. So this is a really great time to get involved, whether you're interested in a leadership position for this working group, we can have a talk about that. Or if you just want to participate as a contributing member to these efforts, you can go ahead and read the charter and what this working group is going to be all about and reach out to me if you want to participate. That said, too, I felt like I should share this recording. We had an event on women in technology a couple of weeks ago. This was to honor Juanita Coppola, who was part of this project. So felt like it was relevant to share.
Yes,
and then,
thank you.
Yep. She has a mention at the beginning of the summit too. And then when me and Mari were the first ones on, we talked about our GuideTech Emerging Technology Conference. So if you missed that, I just shared the link to go register. It's in Annapolis this year. I forget the exact date. I think it's like the end of April, beginning of May. But please go take a look at the agenda and see if that's something you'd like to register to attend, because I'll be there. We'll all see each other. It'll be a great time.
GuideTech is in Annapolis. It's a magnificent place to have a conference.
Yes, it's so beautiful there.
Oh, look at my sailboat.
Yeah, I chose it for my wedding venue. So
Oh, wow.
yeah,
I wanna
extra
be invited.
sentimental.
Congratulations.
Thank you.
Yes, exciting.
So thank you all for being here. Mari and the rest of the team, great presentation. You guys worked so hard on this, I know. So it's really great to see the end product.
It was fun. Thank you for hosting it.
Of course, happy to help. All right, everyone have a great rest of your evening. Talk to you soon.
Good seeing
Thanks,
you.
everybody.
Bye.
Good job, Mari.
Yep, thank you. Have fun.